Hello everyone, my name's Lou and welcome to our demo 2. And so to begin with, I'm going to go over the agenda real quick. So over the past few weeks, we have successfully created the CI/CD pipeline, and we also set up the AWS EC2 server for the Jenkins to be hosted at, and we'll also be able to send data from the demo application to the Datadog APM by now. And we will also going to discuss some our current sprint plan, the burn down chart, as well as the tasks for the next sprint. So I'm going to do a quick demo for the CI, and before I do that, I want to mention that for the part for our AWS EC2 instance. So to begin with, we successfully set up the Jenkins our remote AWS EC2 instance. We installed all the required dependencies. So for example, Jenkins is written in Java, so you need to make sure that in your environment you have the Java installed, and Dockers and all this other dependency like that. And we also set up the security group for that particular instance. So in that way, people inside our group can access the instance remotely but safely. We also pulled the Docker image and then created a container using the Docker image, and then run Jenkins at the port 8080. So now I'm going to quickly show you the Jenkins main dashboard. So as you can see right now, it is up and running on our AWS EC2, and this is our the dashboard for our Jenkins project, and we created a test project that was written in Golang, and when you goes into this project, you'll see that all the build histories with this, and the way currently it is set up is it is triggered every time the Git repository has been updated. Then the build will be automatically triggered. And yeah, that'll be all from my part, and my teammates will demonstrate more.
So now that we've seen how a CI pipeline can be built at Jenkins, let me give a brief intro into what Jenkins pipeline is, and let's also look into some code terms that will be required while writing the syntax for this pipeline. So Jenkins pipeline is a single platform that runs the entire pipeline as code. Instead of building several jobs for each phase, you can now code the entire workflow and put it in a single file called as Jenkins file. Now, there are two ways to build a Jenkins pipeline. So you can either build it locally in your system, and this is known as a declarative pipeline. You create a file known as a Jenkins file, and you start this in the code, basically starts with a pipeline. And you then push this code to a version control system. This is one way to do it locally. And the other way is to directly write the code at the Jenkins UI. This code begins with the node. So these were the two ways in which we can build the Jenkins pipeline. We can now look at the common terms that are used. So like I mentioned before, the code starts with pipeline block if you're building it locally. And on the other hand, it starts with node if you're building it directly on the Jenkins UI. We'll see more in detail as we go through the next slides. The other component that's very important is agent. Your agent basically instructs Jenkins to allocate an executor for the builds. Now your agent can have values such as none, or you can have values such as Docker. An agent can be defined either at the stage level, or it can be defined for the complete pipeline. Now, let's go to stage. A stage basically contains all the work that needs to be performed, and generally each stage depicts a particular task that must be performed. The next term, that is steps. Steps come inside a stage, and it basically defines the order in which certain commands need to be run in a specific stage. So this is a basic, these are the basic steps that you need to configure a pipeline at Jenkins. You start by creating a pipeline. Then once you've given a name, you go to the pipeline tab of the page. And this is where you can write your pipeline script at the Jenkins UI. As you can see, it starts with the node block. There's a stage, which basically depicts the first stage for our code, that is checking out the Git. And the code lies between this. Once you've built your pipeline syntax, you can then build your pipeline. And as you can see, this depicts the status of your pipeline. And the stage appears here. So for our project, this is the basic syntax that we have come up with for our entire CI/CD process. We are currently configuring this part where the Jenkins will automatically take the change code from our GitHub and build a Docker image. We then need to push this latest Docker image to the Docker Hub. Once this is done, we pull the latest Docker image from the Docker Hub and deploy this latest Docker image to a Kubernetes cluster. So this involves both the CI as well as the CD process.
Hey, this is Vinay. I'll be explaining some of the terms and services we'll be using for this project. OpenTelemetry Collector is a vendor-agnostic separate agent process for collecting and exporting telemetry data emitted by processes. Datadog has an exporter available within the OpenTelemetry Collector to receive traces and metrics data from the OpenTelemetry SDKs and to forward the data onto Datadog. This is the difference between logging and tracing. The purpose of logging is to track error reporting and related data in a centralized way. The goal of tracing is to follow a program's flow and data progression. By tracing through a stack, developers can identify bottlenecks and focus on improving performance. These are the steps to push data from an application to Datadog APM. First, we need to configure the OpenTelemetry collector by adding Datadog exporter to the configuration file along with the Datadog API key. If we are receiving traces from the host, we need to determine which ports to open to the container. And if we are receiving traces from other containers, we need to create a Docker network. On each OpenTelemetry instrumented application, we have to set the resources attributes using the languages SDK. Finally, run the OpenTelemetry collector, container, and application container to ingest OpenTelemetry traces with the collector.
As you all know that we are using Datadog for the monitoring, troubleshooting, and optimizing the application performance, infrastructure, logs, and synthetic tests, I will be giving demo about the progress we have made in pushing the traces to the Datadog APM. The application that we are looking here is a demo application in which the client constantly sends requests to the demo server. This is a service map which provides an overview of the services, how they interact with each other. So this service map can be used to check whether a service has issues. It will be color coded eventually, but since we are facing a learning curve, we could not implement that. So it will have the service as green if the services are working fine and red otherwise. Let's say our client service is facing issues. We can inspect the service. We get to see the dashboard where we can see charts regarding the request and the error, the latency in terms of percentile as well, that is 50 percentile, 70, 90, and so on. We can also see the errors by version, the percent of the time spent, and this is the latency distribution. Apart from that, we are also able to check the resources. So in the resources, we can view the HTTP endpoints. Let's investigate on the execute request HTTP endpoint. You'll see similar data as we saw in the service, that is the request error, and the latency in terms of percentile, the latency distribution as well as we get to see the request. So in case if a particular endpoint is failing, we can investigate by clicking on that particular request, and here we can see upon opening the request, you get to see the flame graph. So the flame graph helps you to track the request flow in the microservices architecture, and it becomes easier to track which service is filling. Besides that, we can also check the logs, so to get the detailed information. Although right now it is not set yet, and we are working to set up that along with the infrastructure metrics. So that is pretty much it about the demo.
So the challenges that we are currently facing are Docker configuration for Jenkins, and to determine the correct configuration for OpenTelemetry to send the trace data to Datadog. The goals that we achieved in this sprint are, so we were successfully able to push the trace data from our demo application to the Datadog APM. We got better understanding of Docker and Docker images. We also got better understanding on the steps to configure Jenkins for the CI part. And we also have a skeleton ready for our CI part of the application. So this is the burn down chart. So we had committed for over 40 points this sprint, but we apparently overcommitted and we were able to complete around 28 points in this sprint. Moving on, so the plans that we have for the next sprint are to configure the existing pipeline to include the CD process. We'll also be studying more about Kubernetes to include that in our application for the Datadog part. So we currently are having the trace data that we are pushing from the demo application to the Datadog APM. But now we'll be replicating the same configuration for our actual social network application. And last but not least, we have to deploy the Datadog agent on localhost and EC2 to push the infrastructure metrics to the Datadog APM. Thanks.